Hello and welcome to this video where we'll be talking about object-oriented programming. So in the previous video, we have seen some basics of objects and how it can be used to help us manage complexity when we program our softwares and large projects, right? So in this particular video, we'll be looking at a bit more about different ways that we can achieve object-oriented programming. Okay, so in object-oriented programming, or OOP, uh, almost all code is in classes, right? So you remember that we create class something like color or person, and then all the code goes inside the class, right? So when we write our code in OOP manner, pretty much everything will be written using classes because everything can be seen as objects. Okay, this gives us a new way of thinking about problems and programs, right? So what kind of classes of data are we dealing with? What are the attributes of each class? What operations do we perform on these attributes, and so forth, right? So it can help us use a real-life metaphor. The way we handle problems can be translated into program easier by applying OOP concepts. Okay? So how do you even come up with classes? Well, the programmer has to come up with the classes to use in the program, and there are a few different ways, right? As with functions, we can discover them, right? I seem to have lots of functions taking these three parameters. Maybe they belong together as a type of object, right? So we can discover them, or by top-down design, right? So we evaluate the problem, analyze it. What are the natural data types required here? What are some common characteristics they exhibit? What are the differences? And so forth, right? So similar to functions, we can also define classes for objects in the similar way. Okay. So if you're a bit more philosophical, here's some uh, phrases from the encyclopedia. I'll let you read it. Okay. So when we create an object in its simplest form, it's just a collection of data, right? And we're able to access the data in a simple way. So for example, class point. A point into space, right? So we can initialize that with just the x and y values. Okay? Then we can create point objects, the instance of points p1, 2, and 3 with different x, y values. And then we can print the x coordinate of p1 is p1.x and so forth, right? So what does this mean? Well, we could have created this using tuples, right? But if we do that, we have to use, for example, like indexing. So if P1 was actually tuple T1, then it had to be T1 square bracket 0 for point X and 1 for Y. That's quite cumbersome. If you keep the values X, Y separately, you'll have to pass them both. But by keeping it as an object, you just pass in the object, and inside there you can access the attributes in a simple way. Object dot attribute. Okay. So here's a couple more examples you can see. Here we have a class person. It has name and age. We can create a person. Port 1 is Fred, 27, and we can easily print its name. And it's got a comment there. It's much better than tuple. Why? You can pause the video here and have a think. Well, when we want to access different attributes of an object, we know what those attributes are by referring to their names, right? So this person.name gives the person's name. This person.age gives his age. However, if we keep it with tuples, either we have to access them using indexes, which is not quite clear whether you're accessing the name or the age, especially if you have a lot more attributes. And also, it's quite cumbersome to unpack and repack those values into tuples as well, because tuples are immutable. Okay? So that's why this is much better way than using the tuple. Okay? We also have class unit down here. It can have the unit code, the name, the points, and we can easily create a unit and use its attributes in different ways. Okay? So we can also add the string method like we have done with the colors in the previous video, and other functionalities as necessary. So first thing we're going to look at is the hierarchical classification. In the real world, we classify things hierarchically, right? So we have the animal kingdom. We can classify them with or without a backbone, and then it goes into small further down into more defined type of an animal, right? The humans are also subclasses of mammals, and mammals are subclasses of vertebrates, and vertebrates are subclasses of animals, right? So in object-oriented programming, we can also implement hierarchical classification. Why do we want to do that? Well, because if you're an animal, you're going to breed, right? But if you're a human, you can run with 2 feet. But if you're a horse, you'll run with 4 legs, right? So there are some common methods that can be shared between the instances of animals, but as you go down, you have more customized methods, right? So we don't want to rewrite some of the common methods, but we do want to write some specific methods that belongs to a specific instances of objects, right? So that's where a concept of inheritance comes from, where subclass can inherit all the methods from its superclass, what we call superclass. Basically, it's higher class object. Okay. And the way we declare superclass is very simple. Previously, we had class color, but that's a short form of writing class color, open bracket, object. Object in Python programming is the highest class that every object inherits. Okay, and then we can create a subclass called transparent color, which is a subclass of color. So now the color is inside the brackets. Okay, or we can also create a student, which is a subclass of person. So let's have a look at a use case. Okay, let's consider people in the university. Students have name, address, ID, academic record, etc. Academic staff have name, address, ID, tax code, salary, etc. General staff have all of those, right? So there are a lot of duplications like name, address, ID. But if you have to copy and paste all of that again and again, that's really bad. Okay, so instead, we're going to use inheritance to capture common elements at high level of class hierarchy. And then inside our subclasses, we can inherit those common elements and add your own methods and attributes to reflect the differences. Okay, so if we design our hierarchy of university people, it might look like this, right? So students, general staff, and academic staff, all person that shares these 3 attributes: name, address, and age. Okay. And students are just subclass of person. They're not staff. So it gets the student ID number and also the academic record. Staff have ID numbers, but also tax numbers. Okay. So you see that the ID number exists in both student and staff. So technically, we could have created another subclass here, or put the ID number in person. But if you think about it, not every person will have ID number, right? So if you do want to expand on this hierarchy, so not just student, staff, but maybe public members who may not have ID numbers, then it doesn't make sense. So always when you design something like this, think about its application and how it also can be expanded later on and so forth. Does it make sense to include certain attributes in certain classes? Okay. Anyway, finally, the staff divides into general and academic, where the generals have rate or pay and academics have salary and publications and so forth, right? So here the subclasses are a child class that inherits from its parent, grandparents, etc. So as long, however high the hierarchies go. So here the student is a subclass of a person. General is also a subclass of staff, which is also a subclass of person. Okay. Superclass is the parent of a class. Okay. So staff is the superclass of academic and general. Person is the superclass of student and staff, and also academic and general. Inheritance is all of its parents' variables and methods that can be directly used in subclass. So student will inherit the name, address, and age from the person from the superclass. Okay. So here is the class person, our highest level object in this instance, which has the name, age, and address. Okay, and it also comes with two methods. One is the built-in print method, the string. Okay, and it will tell you the name, address, and age of the person. And second one is a greet method, which is just a silly method, but the person knows how to say hello and greet the other person. Okay, so if we get that, so that's the person. You can copy and paste. Okay, and then in file student.py, make sure that the person.py and student.py and other files that we see later are in the same folder. Okay. Okay. We'll open it. Okay. So inside the student, you'll see that at the very top it says from person import person. Okay. So you have to be watching this video to understand this. So the first one, the person, this is referring to the file person.py. So if I name that as some file.py, then here I will write from some file import person. But you'll know this from functions already. Okay. And inside the student, we have initialization. Okay. Which has a super. I'll explain this in a second. And then student has student.nextId plus equals 1. Okay, self.id equals student.nextId. Then self.record is currently empty, and we have some sort of a method to add the semester grade into the record. Okay. So we can quickly test these things. Okay, so now we're going to import first student. Okay, from student import student. We also have to import person because we only imported the class from the student, so the first line doesn't get executed. So from person import person. Okay, so now we have both student and person here. So I'm going to create this a little bit smaller. Okay, and actually this one a little bit bigger. So we're going to create few people. Okay, P1 equals person John Doe, little Ton 44. S1 is a student, Mary Studios, written 22, and S2 equals another student called Joe Spark, Pendleton 23. Okay, so now we have created 3 different objects, 1 person, 2 students. Print p1.name. Okay, obviously, it knows that it's John Doe. We can go print s1.name. It knows it's Mary Studios. Okay, print s1.address. Knows it's Riccarton. But print s1.id number is 1. Okay, so we can do that with s2 as well, student 2. In this case, it's 2, right? And let me explain why they got different numbers. Okay, and finally, we'll try to do it with P1. But obviously, when we created a person object, there's no attribute as ID, so it's gonna throw an error. Okay, so we can do P1 dot greet and S2 dot greet. Okay, says hello, my name is this. Okay, all right. Going back to the point about student ID. Okay, so let's quickly review our student class. So unlike the person class where it didn't have any person attributes, student have a variable that belongs to the class. So every time a class student has been used to create an instance of a student, then this variable, as you can see here, gets incremented by 1. Okay, and this value sticks with the student. Okay, until you re-import it or restart the shell. Okay, so this can be used to keep track of the number of students in this way. Okay, but the more important stuff is that the student have inherited the greet method, which was not defined inside the student class. Instead, it has the add to record method, right? No greet method, which comes from person. So this way, we can inherit the methods and attributes defined from the superclass. Okay, and how do we initialize values using the superclass? Well, inside the student class, we have seen this called super. So this is a special built-in method that allows the Python to recognize that when it says super, it's going to pass in these attributes into the superclass's initialization method. Okay, so when we call super.init, it's calling the person .init with those values. So this is quite simple. It's just defining the values here. Okay, but by doing that, it also creates the self.name, self.address, and self.age, which can be used inside student class by the student object. Okay. And in addition to those, student has its own ID and self.record to keep track of. So it creates those 2 additional fields. Okay, so that's one way of doing it. But another way is possible by calling the person class itself. Because we have inherited the person, now we have a reference to person from here as well. So we can call person dot and dot init will refer to the initialization method, but we do have to pass in the self. Otherwise, it will not know that this is a student class calling the person initialization method. Okay? Otherwise, you're just creating a person object inside the student class initialization. So what if I want to override the inherited method? Obviously, that's possible. You just have to redefine it inside your subclass. So we're going to open the actor. Okay, so actor is just a subclass of person. Okay, and it just calls the super initialization. So there's nothing else. Everything is same, exactly the same, apart from this greeting method. So it's overriding the superclass's greet method by printing greetings and delicious. Okay, from the maestro, right? Name. Okay, so let's do that. We're going to from actor import. Oops, typo. Okay. From actor import actor. So that's done. And then we're going to create an actor. We already have P1 defined. P1.greet, okay, which is John Doe. So we'll just keep on using that. We're going to create an A1, which is an actor. Give it a name. Lives in London. 57. Okay, so now we created an actor object, A1. So we can go A1.greet. Then it's going to say not hello, but instead greetings and felicitations from the maestro Kenneth Bernard. Anyway, so obviously this shows you that we can override existing methods that you have inherited from your superclass. Okay? Sometimes this can be useful, just like this actor who wants to greet in different way. But if you think about this from a style perspective, it can be questionable. So you have to make a good judgment on this because the subclass no longer consistent with the superclass. Okay, so the whole concept of inheriting is because it exhibits the same behavior. So if it starts to behaving differently for the same stuff, then are they really superclass subclass relationship, right? Okay. So here, a quick check before we moving on is the type checking, which is a one-way thing. And this can be used to check whether objects are of an instance, right? So here, x equals 5, and obviously type of x is integer, right? And we can use the built-in function is instant x. Is x an instance of int? Well, this is going to be true, right? Because that's what we just saw before, right? Is x an object, right? Well, obviously, int is an object in Python, which is a subclass of objects. So this is also true, as shown here. Okay, but is object an instance of an int? Well, this is checking the subclass superclass relationship. So this is false, right? So we can apply this to our person class here. So is instance is A1 instance of an actor. This is true because it's clearly an instance of actor. We can also check, is it an instance of a person? Well, person is a superclass of actor. Therefore, we should get true. Okay, and obviously it is also an instance of object. Okay. This way you can quickly check whether certain objects belongs to a certain superclass or not. Okay, and this can become quite handy sometimes for sanity checks, but make sure that you are not using this as part of your code. This is really for you to check things rather than using it as a feature in your program. Another concept that we will cover in this video is polymorphism. Okay, it's a cool word, but it basically refers to the ability of some bits of code to handle different data types. So for example, the addition that we have seen is actually a polymorphic operator because it can be used with integers, strings, floats, lists, and whichever you create that allows addition. For member in collection is a polymorphic construct because it can handle any iterable. So the collection can be a list, tuple, dictionary, sets, and any other iterable objects, right? Len is a polymorphic function because it handles any object with a len method defined. So len can be used on a string, len can be used on a list, tuples, etc. Right? So all of these are doing something, whether it's an operator or in a collection or as a function. It takes in multiple data types and be able to process them. Okay, and this is an important concept in statically typed languages because they are often fixed in doing what they have been defined to do. In Python, we can create variables on the fly. We don't have to worry about its data types, but in statically typed languages like Java, C++, once you define the type of a variable or its operations, then it's fixed, right? Hence, the use of polymorphism is a lot more important there. This is not so important in Python because we can do things quite dynamically thanks to Python's duck typing. Basically, if it walks like a duck and quacks like a duck, it's duck kind of behavior. Okay. But it's a really important concept in OOP, especially if you're trying to use different language like Java and C++. Okay. So inheritance provides subtype polymorphism because code that handles base type works for any subclasses. So we actually have implemented some polymorphism in our code already when you define like the string method or the addition method for the colors and so forth, right? So these are all concepts of polymorphism, which you might find handy later on as well. Okay, so finally, when do we want to use inheritance? Well, as discussed before, identifying the attributes, the methods, and how to design different objects, how to design the hierarchy can be quite challenging. So it is a good idea to have some sort of a rule or guideline that defines how you can create inheritance. So you use inheritance when you have the is a relationship. So for example, student is a person. A rectangle is a drawable object. Okay? A value error is an exception. Right? A science course is a course. Right? But do not use inheritance when you see a relationship that is a has a or can do relationships, right? So for example, a course has a list of students, right? But it isn't a subclass of lists. Okay? A person can do swimming, but fishes can also swim, right? So it's not an inheritance, right? So just sticking to these rules, you will probably be able to create, you will probably be able to apply inheritance in more appropriate manner. All right, so that's it for this video. Hopefully you found some more advanced OOP concepts useful. You'll definitely get to learn more about these later on, so it's a good idea that you get a good grasp of these concepts now. Okay, so that's it for today's video. See you next time. Bye.